Good morning, friends. My name is Vipul Kumar, and today I'm going to show you about how to program on a quantum computers, especially on IBM quantum computers. Yes, so our objective is to get you familiar in a programming with the quantum computers, and our main goal is to perform below. I need to find the probability of getting a head and tail in a coin which we tossed. And if you look at this diagram represents what we are going to do in a quantum computers. Here head is represented by your quantum bit, H represents hard amount, X is your NOT gate, and that's it. And this is, everyone must know and aware about that. Everyone has read about in their academics about Heisenberg uncertainty principle. So I want that you should aware about that, what it exactly is. This is nuclei. This is your energy high and low part. This is your electrons. Alright, so to do the above goal, I will performing on my computers, and this computer is a Raspberry Pi and on IBM quantum computers. So I'm going to execute same code on my Raspberry Pi as well as on IBM quantum computers. So my approach would be a classical one, using a C program, using a random with a seeding in a randoms, and using a Qbit Python module to work with the quantum computers. Alright, so here is the code for programming in C, program written in C for finding the probability of getting a head. Let's run this. As you can see, the probability of getting a head is much more than getting a tail here. It's almost like 55 to 56%, I would say, and 44% is getting a tail here on classical computers. Now let's do the same thing on simulator with a Qbit. Okay, so this is a beautiful picture, a circuit. Q stands for qubit, H is your head amount, X is your gate, and measure. This is something like you measure the qubit and store the results from a qubit to a classical bit via this. So let's run this code on the simulator, which is here at my system on my Raspberry Pi. Alright, so we get that it does not generate any randomness, only possibility of getting ahead is 100% here. So on simulator there is no luck. Let's do the same thing on IBM quantum computers. It looks the job is queued. Oh my god, 3. So finally job is actively running here. Come on. You are quantum computers. You can't be so slow. I'm sorry, it's not about slow. There are many works out there where they are executing their jobs. So finally it runs successfully here. So let's plot the diagram. Okay, so we get that possibility of getting head is much here, and the tail is less, which is quite different from every scenario, to be honest. Look at here, this is like probability of getting head is 100% here. It was on a simulator and it was on my Raspberry Pi running the same program in a C language. It's almost like a 56% and 44% of getting tail. So this is what I would like to convey you from this example, that how things work on a different systems. Thank you.